All right, so there you go. So this is our drawing board. We are going to be extensively using the drawing board. It's not going to be PPT because I don't like PPT. I cannot think with PPT. I can think when I'm writing, and when I'm thinking, I like to write. So I'll just use this OneNote. Do let me know if you're able to watch or see the screen properly. Or if anyone is not able to see it, let me know. That would be the simpler explanation. If I ask if you're able to, then 30 people will have to be, you will feel that the need to answer. So if anyone is not able to, let me know. I guess everyone is able to. Fine. So welcome guys formally to this summer school on machine learning, AI, data science, however you would want to call it. The end result of this should be that you would absolutely know the difference between all of this. You should be able to reason with yourself why you want to take this as a career or why you don't want to take this as a career. Okay, this should be that kind of a course for you. How much can you expect? How difficult or how easy it is for yourself? So all of that we are going to be understanding. When we start that, while we try to start that, we have to first understand one important thing. AI, artificial intelligence, of course it is artificial, machine learning, the machines learn. All of this is possible only because of data. Data is the fuel. Data is the new money. Okay? So it is important for you to understand what is data. On that end, I would say data is the byproduct. Follow me on this, okay? Data is the byproduct of observation. Now, whether you actually choose to record this observation or not is up to you or up to the person who's conducting an experiment. But it is always a byproduct of observation. If you observe carefully, you can get some, like Sherlock Holmes. Sherlock Holmes' greatest ability was to carefully observe and collect all the data that may or may not help him solve the case. But collection of the data is important for the person. Later we will decide whether that data is important to form a hypothesis or not. But observation, keen observation is important. Now this being a simple English statement which makes sense to most of the people, we need to reduce it to an engineering experiment. Observation comes in many ways. You can observe using images. You can observe with video. This particular observation is happening as a byproduct of an image plus audio. You can be just collecting sensorial data, sensor related data, just like your automobiles are collecting all the acceleration, GPS, all of these data. Your mobile phones, all the Google products are collecting your activity data. So somebody is either really observing as a human or they are observing as an automated process using technology. Now this was happening from a long time. This has been happening from a long time. All the companies which had invested very well in this kind of data recording, now they are reaping the benefits of AI. And suddenly there is a completely new trend now for all the companies to go data driven. So they are investing. That's a big future where a person actually learns how to collect data and how to assimilate and store it in a database, which eventually is called big data. So big data, if you guys are wondering what big data is a large amount of data. And when the data is very large, it comes up with its own problems. Where are you going to store it? Whenever the data scientist requires the data, if the data is large, the data scientist wants to make an hypothesis. Are you going to stream in all of this data at once? Or are we going to bring out some new way of crunch the data in a different way and give the data scientist in part by part or phase by phase? These are the questions which a big data engineer will be required to know. And of course, technology, big data science, and all of that has been done. It's a structured science now. So if you learn enough about the big data paradigms and how the cloud works and how the data is distributed, all of that, it is going to be a subject which can be a mastery over which can be easily achieved. The challenge, however, is actually building predictive models. How do you build predictive models? You have past data. You want to predict the future. So this is where the challenge is, and that's the reason why you can see many advertisements, or the trend is the data science is the best job of the future. And again, there's a new trend which says, oh, data science is just was a hype, it is going to die out soon and all that. Now, I'm not going to say anything about this. Okay, after 15 days you should be able to make an informed decision about what's happening, because that's half of the knowledge or the creed or the ability of a data scientist or a machine learning engineer is to be able to find the domain where data science will be applied. This domain can be anywhere: mechatronics, electronics, financial markets. Even chefs can use data to predict or create new kind of recipes. You can Google. People are using AI to bring out new kind of recipes. So what happens here is, once you understand the entire crux of the matter as to what is prediction, what actually is prediction. It could be something you thought it's from like future, watching sci-fi, or you're trying to build Jarvis from Iron Man, right? That is of course the ideal expected future, but we'll understand how it works. What are the complications and stuff, we'll understand all that. So first, before we start, let's understand the types of data. We have done everything, we have now understood that data is the core. But we should also understand, when we talk about data, is it just any data, or is there a room for us to actually classify this data without any ambiguity? Without any ambiguity means, let me see if I can order it. So we should not have any confusion when we say. Tell me, anyone's got a doubt? Anyone has any doubt? Somebody unmuted. Apurva Jain has a doubt. No? Okay. Guys, there will be doubt sessions. Don't worry about it. I'm happy. I like teaching. And make sure that you write down that doubt. Okay? When you have any doubt, make sure you just don't be a spectator. Have a small piece of paper, think with me. Think, get into the thinking mode, just don't come into the listening mode. I may go wrong. Some student here might be more learned than me, much more better informed than me. I'm happy to have that person. Okay? If you find a better answer than what I'm giving, let's discuss. Eventually, I might end up learning more. That is fantastic. Because here in this case, I'll be getting paid to learn more, right? So I'm happy about that, right? So I'm opening. I am a very open person in that end. I like discussions, and with every discussion, I get to learn more, and our lessons get better and better. Now tell me, guys, is it visible, adequately visible, the screen? Whatever is written here, is it properly?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Perfect. Perfect. Thank you. So types of data. One is quantitative, another one is qualitative. Let's read the definition, then we'll try to make sense of it. Data that can be measured with numbers such as duration or speed. Qualitative, non-numerical data that is categorical, such as yes or no, responses, or eye color. Now, where does data come from? Data come from observations. Now, if you are going to observe, if I'm going to ask you, how good was Avengers? Okay. And you will say good, very good, nice, fantastic, loved it. So many expressions, emotions, which describes quality. How long was the movie? If I ask, you'll give me numbers. A phenomena which has been observed every time is a combination of numbers and emotions. Because are we trying to predict something just for the sake of it, or are we trying to predict something for the betterment of our own observations or betterment of our own lives and automations and all the affairs that we have? It's because we want to get it better, right? So numbers and emotions are always a part of this data, expected to be a part of this data. Sometimes it is not. Sometimes you're just talking about stock market data. So in that case, we are going to just be using regression analysis to predict what happens in the next future. Fine. So sometimes you are building a recommender system, like Amazon, like Netflix recommending movies for you. In that part of the problem statement, you will use both numbers and emotions, the genre, the quality. But quantitative data is that data which is generally comprising of emotion, and quantitative is about numbers. But quantitative further can be unambiguously divided into discrete and continuous. Whole numbers that can't be broken down, such as number of items. This is discrete data. I guess you agree with me. Whole numbers that cannot be broken down, such as number of items. This is a okay definition, but you need to understand why this discretization had to be separated out. Let's have one example where you understand what kind of data this is and what are the times when this kind of data comes into the picture. An example of that would be, if I am going to ask you, of 30 people over here, I'm going to ask, let's say all 30 people, how many products did you buy online in 2020? Now, I'll get 30 answers from you guys. Do you think any of that answer will be in a decimal number? It cannot be, correct? You will never buy half a product. by the nature of it, the product or the experiment here demands the answer to be a discrete number. So when you are observing and when you are dividing this particular section into discrete and continuous, you are doing it because you know that this one, when you know it falls into discrete category, it is actually talking about data which is talking about the phenomena. This sees the connection. So this boot camps, how to, and always any course will be about how to and why to do something. Now, how to is a long process because so many hows are there, right? It's a long list. So usually you'll see big courses, MTech degrees, and there where you'll understand both how to and why to. When there are short courses, like 15 days, we focus more on why to, which is going to engender the further how to's for you. Okay, so that is why I'm going to delve more into why to of things, and hoping that you guys are mature enough to put together the numbers and get the right additions or subtractions or multiplications that you would see fit. So having said that, I hope you understand the discrete events. Another example of it would be how many times Virat Kohli won the toss, or Dhoni won the toss, or all the captains of yesteryears with India in cricket team, from starting Kapil Dev to all the captains. How many people have won the toss? How many times? If I ask, if you make a table and send me, I'll never again find a decimal number because the phenomena itself warrants a discrete event. Now with this clear, it's easy to understand that numbers that can be broken down, such as if you want to measure height, you can measure height as just say 6 feet. If somebody is going to say, no, that is not enough, there are so many 6 feet, I still need to order them. So you'll go measure it better. Then you'll have 6.1, 6.2, 5.8, whatever it is. Weight, the same thing. Or how much fuel you have, same thing. So continuous numbers are numbers that will allow you to have decimal numbers, and it is usually happens when you want more and more accuracy. It allows for accuracy, right? But in discrete, that's it. The phenomena itself is, that's all you'll get, a number. Accuracy only probably more observation will lead to probably a number, a jump in the entire discrete number, but you will never get into decimal. Please understand this very carefully. Anyway, this recording will be shared, but if you want some time off, some moment off, to just make a note somewhere, if you have a doubt somewhere, have it. And in all my classes, in all the major courses people join, we conduct something called TEs. TEs is called thought experiment. Trust me, any learning you want to master, it starts here. You start with a thought experiment and then connect the result of your experiment in your mind to the concepts over here. This is enforcing your neural network, your own brain, to actually make place for the learning. Okay, this should be important. And while I wanted to say that, I also had in mind, so good thing I remembered this, I have to tell you this important thing, or I'll give that to you as an assignment. Take it down. Let me pull that out. I don't remember the names properly, so I need to go to my references. Okay. Take this down as an assignment for today. I'll rub it off later, but please take this down. Google such a bad thing. I could have done this. Please Google this, okay? Why I'm saying this, you will understand after you read about this. Right? So, let me move on. Shall I delete it? You have made a note of this? Or you want me to send this over in public chat? All right. So what next? Quantitative is done. Qualitative. Under qualitative, nominal and ordinal. Who divided it? Who gets to say that this is the final decision? This is the final division? Who makes all these decisions? Well, it doesn't matter who made it. Great minds have made it. But you have the decision to accept it or not. So now I guess quantitative and qualitative you accept it. Discrete and continuous you accept it because there is enough good reasons. Same way discover the reason for this. Nominal and ordinal. Data used for naming variables such as hair color, type of laptop, type of the microphone that I'm using, what is the name of the platform that we're using, all this. Nominating. Nominal and then is ordinal. If there is any nominal data that can be ordered, for example, how good was the movie? Good, bad, time pass, worst. Automatically there's an order there, whether you want it or not. But in nominal, okay, which college students are attending? Let's say it's a multi-college event. So there'll be many colleges. So I'll get all the text. So can I order it? Can I order it in any form? Okay, if you want to bring in some extra data over there saying that let's have ranks also or a number of people who are in the universities or different categories in which you'll add an extra layer of data over here, then probably you will have a reason to order it, right? Otherwise, if you just give the names, you cannot. However, sometimes just with the name, like good, bad, better, these kind of names, you can actually order it. Such as 1 is equal to happy, 2 is equal to neutral, third one is unhappy, you can order it. This kind of data also comes out of a phenomena as a part of data, right? Fine, this is understood. Now, interval and ratio. Where is it? In continuous data. You will find intervals and ratios. You will find intervals and ratios, of course, in discrete also, but we are more concerned about intervals and ratios in the continuous data, where continuous measurements have been taken. So interval is numbers with known differences between variables such as time. Means when you put an observation, when you decide that let's take an observation and put it on graph. For example, COVID data, how COVID infections rose from a certain beginning of time. Let's say, when was it? Around March 1st, I guess. It started March 1st, 2020. I think the first case was registered in India. So from there on, if you start making an observation, on x-axis you will just put number of cases, and on y-axis you would decide, okay, on x-axis not number of cases, on y-axis it is number of cases, on x-axis is the time. You can simply choose time in weeks or time in days or months. Automatically when you say weeks, days and month, you already know the differences between the variables. That is interval data. You already know. If I just put 1, 2, 3, 4 and I tick W, automatically it means that between 1 and 2 there are 7 units. If I would do tick days, between 1 and 2 there is only 1 unit. If I tick month, Between 1 and 2 there is again just 1 unit. But 1 and 2, okay, there are 30 units, right? In terms of how many smaller units this particular jump is made of. So that is what is interval data. But sometimes you will not find this luxury of having time always as your x-axis. We are not concerned about how it moved in time. We are concerned about how something moved with respect to something else, how height is moving with respect to weight. Okay, so there is no time, so we don't have any particular interval, so height and weight. However, some interval difference can be determined. There will be hidden intervals over there. If such hidden intervals are present because of previous observations, previous research that has been done, that we will conveniently call as ratio data. Okay, so see, most of it probably from here on you can actually have a debate on, no, we could have done something else. Maybe there's a bigger a division, or we could have much gone deeper and gotten here some other 5 different sections. We can have a lot, but the whole exercise of this is to get us footing. You start here. You want to start data science, you want to start AI, you want to start machine learning. This is where you start comfortably. All right, so this is about data. So let me know if you want me to explain something here again, or if you say move to the next phase, I'm ready to move. Initially we're going to be slow because it's very important to be slow in the beginning. After that it makes sense to pick up the pace because you guys would be mature enough to know what's to be done and what not to be done. Am I audible, or have I muted myself, or everyone's gone? Okay, everyone's
audible,
Audible,
sir.
sir.
Audible, sir.
Sir, you are audible.
Thank you. So far so good? Making sense?
Yes, sir.
Yes, sir.
Enjoying
Yes,
the
sir.
class?
Sir.
Yes, sir.
Fantastic. Make your notes, make your small doubts, and post a doubt in the group, and we will. Tell me how many people were very curious to Google this right away while I was explaining? How
Sir,
many?
me.
Did you find out why it is important?
Yep, sir.
Yeah, fantastic. All right. All right. So, see, we talked about different kinds of data. This is a general category of data. Here you have a small picture which talks about data from different kinds of phenomena, not about how it is structurally or different in terms of its definition. This is just different in terms of its existence. Okay, like there is structured data. Sometimes you get very good structured data. For example, the data I collected in Excel sheet from all the Google Forms data that you filled, I got very good structured data. Now if I were to base only on a WhatsApp link, if I would just say there is no Google Form, there is nothing, just join our Google community, community, and put all your screenshots of what you paid and what you want, what course you want. Imagine how the data will look like on my this one on WhatsApp. If I just save the chat and then I decide that using this chat information, then I'm going to contact everyone to join this course, to join that course, and blah blah blah. That is unstructured data. And the kind of projects we did for some defense agencies was, by nature they were getting unstructured data. There is no other way to structure it because the data comes like that. The observations, the human intelligence, that data that comes up to the central command were all unstructured. we had to write an algorithm, develop a pipeline. It is not just an algorithm. We have to develop a nice pipeline to take this unstructured data and make it into structured data. So we developed a small tool called flagx. So after it gets structured, I'll show you. In one of these classes, I'll show you how it works, and you will see how the whole thing takes up. You give me any data, and we'll be able to create automatic filters and get it into structured data, and then download it as an Excel sheet. So we did this, okay, and it's not that big a deal. It can be done. No Brahma Gyan required over there. Anyway, so geographic data, all your tiles, your tiles on the earth, GPS data, where is what, location, all of this called spatial temporal information, all combined. This is geographical. Real-time data, you understand. Natural language data, where it is? Twitter. All the people who are sending out messages on Twitter, if you want to analyze who's liking what is the trend going on, if you analyze the Twitter data 30 days prior to the day of an election using natural language process, natural language has its own, it's a field in itself, right? Natural language processing, it's called. It goes into the construct of human languages. And from there you will find some repeated patterns. Using those patterns, let's say we build some algorithms and we come and analyze 30 days of Twitter data before an election. So with this kind of thing, you can actually sort of predict the probable winner of that election, right? So time series data, everything time series, you have stock market. Time series automatically means on x-axis you will have time, and on the y-axis, which is the dependent variable, you will put anything that you want to measure with respect to time. So if you want to measure a phenomena as if it is depending on time, and you want to say how it is depending on time, you will put time on x-axis and everything else, if you have, on all the other axes that you have. If it is just about, let's say, how in time your weight increases, so you can have just time here and weight here. You can, if you say, I just don't want just the time, just the weight, I want a lot of things. I want weight, I want height, I want salary, number of friends, so many dimensions, but all of them based on time. So we'll have different graphs, different relationships, as you know, it's like as time increases, your weight though definitely will increase, because that's a natural. Of course some people will lose, but those are called exceptions. Fine. The weight increases, salary increases. If your weight increases, then definitely your friends are increasing, because you have been partying too much with the friends, eating, drinking and stuff. So definitely number of friends will increase. I'm just making just assumptions over here. Don't take me seriously on that. So I'm just giving you different ways of observing, right? So event data, this is an event, so there's an event data. Network data, if you have all the different kinds of for example, here we had this pipeline, so all this data is getting collected from some terminal, so all the data that is coming up with network. But when you're talking separately about network data, you will have different fields over there, not just the data. You will have some attributes related to the network, which IP address gave it, what was the timestamp, right, and what was the it's called I just forget this. There's a term which actually checksum. Yeah, it is a checksum. Okay, it's called checksum because let's say some network decided to send some 21 bytes of data, And we know, we already have declared that in this network every time you will get 21 bytes of data only. So the receiving end will wait until it has received 21 bytes of data. If there is an issue and there is a power cut or some hiccup and it just got 19 bytes of data, it is not going to consider that data transferred. So the checksum has received or not will go back. So network data, you're understanding? Everything is a domain in itself. Linked data, linked. So we'll understand. There's a lot of, this is just a small layer. So we just understood different kinds of data, the classification of data based on its own, definitions. Very generic way of understanding, which will never change. This is a rigorous, unambiguous representation of data, which is going to stay forever. Learn this, map this in your mind. All your algorithms, your processes, your attempts at data science should start from here. You should first ask question, what kind of data am I dealing with? Is it combination of these? Is it an ordinal data which has all these? Does it have ratio in it? It is only discrete. Is it a combination of discrete and some ordinality? Many combinations can happen. So based on different combinations and how many dimensions you're dealing with, different machine learning algorithms will come into place. Okay. However, this data is domain related data. So you should look at this data, each of this circle. When you look at this, then after looking at this, try to observe this. Structured data, again, try to discover this. You want to make an unstructured data into structured data, you have to go through this and then make it structured. See how it is linked. Trust me, when the lot of when we take up something like this course, a new thing, a new field, it takes time. Okay, and you'll be surprised if you keep doing it long enough. You'll be surprised that now, even if you want to, even if you try hard, you'll not forget it. Same thing goes for all the things that you've studied, the language that you picked up, the skills that you picked up. It's because of repeated practice. Earlier, when you were in school, somebody actually made you go through all that. Your mom, your tuition, your dad, your teachers were behind you. You had no option. But problem when you grow up is you have options. You can, after this, probably this class, you can choose to go and refer and redo the whole thing, or you can go watch Mandalorian if you have not watched it, and as a series, a Star Wars series. And if you're watching some interesting series in the middle of it and you decide that I will watch the series first, then at night I will revise it, you have just flushed away all the effort that you put in just staying here and listening to this lecture. Trust me, it is harder to sit for 1.5 hours and listen, and it is much more fun for me to talk about this for 1.5 hours. The difficult part is what you are doing, not what I am doing. Because I love this. Every time my lecture will be different. Every time I do this, I'm reinforcing it. You guys should also do the same thing. Indirectly, I'm saying, first do the revision, then have your other entertainments. Okay? That is going to work well for you. All right. So this is where we are going to wind up the idea of what data is, assuming safely that you have understood the whole concepts. Okay. Anyway, so I come from this domain, Spatial Temporal Information System. If you can Google AGI, Analytics Graphics Incorporated, there was a tool called Systems Toolkit. So I have worked in this domain for a long time, dealing with all kinds of data related to drones and satellites and radar data. So I've worked in each of these fields, particularly with Air Force, and then I worked with the Radar Establishment of India, with Navy, with military, all that. But everywhere I worked, I only worked on data. But my field, my MTech is in actually astronomy and space engineering. So the space engineering aspect, Here I had to learn a lot about spatial and temporal, means how something is positioned in space and how something is positioned in time, and how are those assets moving, whether it can be radar lobes, how it changes, how on a particular orientation, how much data are you able to capture about the enemy. If this turns, you put a camera over here, let's say, and now what happens if you put a camera over here? If something else comes over here, your own body is masking the camera. So we now decide where to put the camera, which is going to get the maximum amount of, right? These kind of data analysis related to this I used to do. Okay, so this is my domain. This is from where I come from. All right, so let's understand now let's go on a journey. I call this the story of X. This is very important with respect to machine learning algorithms, the construct of it. We have understood the construct of data, from where data, how to look at data, right? Now we are going to understand how to look at the whole idea of prediction itself. Now prediction is about a phenomena. Please understand, this particular section is very important. You want to predict a phenomena, but you want to predict this, right? To predict, you can only predict when you have quantized data. Very important. Write it down if you want. Write this down and paste it on your wall. Because you go and ask anybody from the past, go ask von Neumann, you want to go ask Einstein, or you want to go do a time travel and ask different scientists 100 years later, this will not change. Phenomena predict. To predict, you have to quantize data. What is the meaning of this? Means you have to reduce the phenomena to numbers. It can be movie phenomena, movie rating. It can be anything. You want to predict how good the movie is. Good, bad, nice. That good has to come as one number. Bad has to come as because who is doing the prediction? Machine. And machines can only understand numbers. So a good data science experiment, when you observe the phenomena, you should have the know-hows and the skills and the maturity, the knowledge of reducing this phenomena to numbers, which in technical parlance we call it quantized data. This quantized data is going to be used to predict. So how the whole quantification of data has evolved is what we are going to start with, the story of X. Okay, it's a very small simple story of X that I created, just my own version. You can, after listening to that story, you can tell me how I can improve it. I'll be happy to do that. But tell me guys, do you think we have 45 minutes? Because our schedule says it ends at 5:30. But if I start this now, I'm pretty sure that it is going to go till 5:45. So do I have that kind of time, 5:45, 5:50, so that I can take a 5 minutes break, some water break, and start maybe at 5:15 and end it at 6? Or much more than that, much before than that? Do you guys have time?
Yes, sir. Go.
Yes, sir. Yes, sir.
Yes, sir.
Who doesn't want it? Who wants to? If you want to leave, you can. You will get the recording. Okay, no worries about it. But I would suggest you stay on. Okay, so let's take a small break, about 7 minutes. 5:15, we'll be back. Nothing changes. I will just pause the recording. I'll just mute here, and 5:15 bang on, I'll start the story of X. How about that? Right?
Okay, sir.
Yeah.
Fine, sir.
Right. Thank you. I'm just going to okay guys, I'm back. Hope everyone is here. Do you want me to wait for some time? I'll wait for a minute and we'll start. done, just push the door and go. Thank you. Okay. So, shall we start?
Yes, sir.
Yes, sir.
So, let me take this small. Yeah, so where do we start? Journey of data and evolutionary context. We start with the thought and appreciation of the fact that human brain is a reverse entropy engine. It means that universe is always trying to get into chaos. There's so much energy which is unstructured that, and that's how it is, because all energy moves from higher potential to lower potential. The idea of moving to lower potential where there isn't much work done, the whole process looks chaotic actually. But when you're trying to build something from lower potential to higher potential, you will be doing a lot of ordering. So the measure of disorder, the measure of chaos is called entropy. And if you want a definition of what kind of an engine a human brain is, it's a reverse entropy engine. It is going to reverse the entropy. That's what we are trying to do all the time. We want to get educated, we want to get up at the right time, we want to be structured, disciplined, and all of that to reverse this entropy. And this is a part of, this is how we are, this is how we are designed. Okay, this is the success of human species, because somehow by some stroke of luck, the structure, the whole gist of our being, our existence relies on this. Who's playing?
आंखों में तेरी अजब सी अदाएं हैं, हो आंखों में तेरी अजब सी अदाएं हैं। दिल को बना दे जो पतंग सांसें ये तेरी वो हवाएं हैं। आंखों में तेरी अजब सी अदाएं हैं।
Am I audible?
Yes, sir.
Yes, sir.
Who played groovy over here? Who brought in groovy? Somebody who knows what to do. Somebody who went into somewhere and used some bot command over here. Groovy has used this. Who's this? Who's this? Jasmer. Is Jasmer a part of this group? Jasmer is here. Yes, Jasmer. Jasmer, you are a part of this group. Yes, Jasmer.
ग्राउंड फ्लोर फर्स्ट फ्लोर में यार, फर्स्ट फ्लोर में जो आई का बालकनी है ना, हाँ
Jasmer,
अरे क्लास कर रहे थे।
Okay, see, you're still able to see this. This is going to be recorded. And when you do some experiments like this for your own stuff, it actually disturbs the whole thing. Did you guys listen to the music, what was being played suddenly in the middle of the session?
Yes.
Yes, sir.
Yes, sir.
Shanti Om.
Yes, sir.
Yeah, so good choice of music, no doubt, but wrong timing. Okay, I guess Jasmer was just trying to experiment something and thought he will just listen to music while he listens to this whole thing. But if this repeats again, this experimentation, I would be removing that person. Okay, don't do that again, because the flow gets disturbed. Where was I? Right. All right, guys, sorry for the inconvenience. Let's begin. Let's start. So as I told you, universe always tends to get to chaotic, right? So Jasmer has proved it right. Despite our reverse entropy effort, there will be always some random act which is going to bring in chaos. And okay, I have to share the screen again. Who's not able to see the screen? Did anyone?
Sir, it's already shared.
It's shared. Somebody just
Yep.
messaged me saying they're not able to see the screen. Kindly just, if you're not able to see the screen, go back again to the live and watch the stream. I'm seeing 30 people are watching it, so I guess I have a 30 head count over here. That's not a problem. Okay. Right. So having said that, this reverse entropy thing being the nature of our minds, let's go and look at the prehistoric problems that a nomadic civilization, human civilization, would face. The first problem was a problem of counting. You can see in this picture, life is very simple. The picture 1, a simple structure, just about 2 cattle and a few number of people. So the problems that the person here or head of this family or this estate had to deal with is simple, right? So this is easy to identify 2 things, 2 houses. It's easy. You don't have to actually build a number system to handle this system or handle this case. But as life becomes complicated, our businesses, our dealings become more complicated, the assets that we have increases to 5. Still probably can handle, probably still you can make out the difference between 2 and 5. You may not know that it is called 2 or it's 5, but you can still when you see, you can still feel that it is bigger than this. But when something like this happens, there is a need for a system. Okay, so this was the evolution. The system, the need for the system evolved, gave rise to numbers. So this is the evolution of what led to what and where we are now. So of course, when numbers came in, they gave it came out with the different symbols across the world. The Arabs, Hindus had different different symbols of representation. Romans had a different kind of representation, which was like this. But as you can see, imagine doing data science with this kind of number, right? Not possible, right? Imagine building a computer with these kind of numbers, not possible. So one of the number systems gets selected. That is like evolution. So the best one was having these kind of symbols for each. And of course, the most beautiful thing was the symbol of 0, which stands for nothing. The great genius of the whole idea was that the person decided that this nothing should also have a symbol, right? So that was the beauty of that representation. With 0 came the new numbers and the repetitions and so on and so forth till infinity. It's an idea of how numbers increases. Now with this, there are other kinds of smart people who come into the picture, and they'll see patterns among these numbers. They will see patterns. They will see that, okay, there are certain numbers which can be divided, certain numbers which are composites, certain numbers blah blah blah. So the pure mathematicians are going to deal with this kind of internal patterns, the prime numbers, the odd numbers, the even numbers. There's a pattern here, right? It's a beautiful world inside. People have spent ages on it. They have spent decades trying to get into these numbers. Of course, Ramanujan, as you know, is one. Now what is happening is all those work, beautiful work that has been done by those pure mathematicians, they did not know that their work would be used later in future. They did not know that. They just did it for the pure passion of it. But now it is being used. All these techniques are being used in cryptography, blockchain, data science also, statistics, because the patterns will lead to hidden truths. So the summary of this is, with time the representation systems evolved. This evolution led to higher levels of abstract thinking. What is the meaning of abstract thinking? Abstract thinking means, given a certain phenomena, given a certain problem, here you abstracted the idea of counting in terms of symbols. That's the first level of abstraction. The second level of abstraction is getting 0 as a symbol. The third level here is ... till what? Put another symbol, and now the symbol means infinity, that it will just keep on happening. So as and more you keep introducing symbols, you are actually abstracting a certain definitive quality about that progression. Now don't ever be afraid or confused when you look at new symbols in your research papers. All those symbols are abstractions of certain definitive quality. And once you dig into the meaning of those abstractions, you will no longer have any emotions of fear or disgust or frustration associated with symbols, because now you are enjoying the phenomena of that abstraction itself. That is learning. Okay, that is when you start enjoying the whole process. So we are looking at a simple story of abstraction here. So counting numbers evolved as a system which represents a series. Many series, 1, 2, 3, ... a series of even numbers, 2, 4, ... series of odd numbers, 3, 5, 1, 3, 5, ... and prime numbers also, right? So it evolved naturally. People explored it. They went ahead, did a lot of great things. The next question, the next sort of problem that evolved can be put out as a story between, let's say, some prehistoric man and another prehistoric man. They just want to, let's say, trade between each other, and probably the assets that they have to trade is a piece of land. So to trade fairly something, you have to quantize its value. Quantification of the value, which is a physical value. This is actually a physical, real estate, it's a physical value. This led to the evolution of geometry. So it's like asking a question, what is mine, what is yours? The next level of abstraction, calculating areas. They made a very simple system out of it. L and breadth. Length time breadth. So if you take this as some length 8 and the breadth as some 5, you have to put 5 times this quantity of 8, and together whatever the number that comes out of number system, this would be the representation of the value of this geometric figure. Okay, there is nothing much to it. These are all numbers with associated logic in it, and this is how everything, if you want to take into the most complicated calculations, is again all simple representations which everyone agrees to. Okay, here in this case, the next evolution, the next abstraction was the abstraction of geometry. Internally, there are many different abstractions which goes from here. Okay, but we'll come to that. Now, the next issue with prehistoric person, what was that? Where are you? Where am I? If you need to go, if these two people actually, let's say, belong to different places and they somehow meet each other and they say, hey, I have something, you have something, I want to live near the house, near the hills, you want to live near the beach. So why don't you come and check out the small piece of land that I have? I'm tired of the sea, so let's have an exchange. The question is, how do you tell them where to come? Because we don't have GPS. Back then there is nothing. There are not even roads, no milestones, no systematic city layouts, nothing. So the next problem to be conquered and to systematize was the coordinate systems. So the coordinate systems evolved and many systems came up. And while that happened, one, I think he was a French mathematician. Yeah, French mathematician René Descartes. Okay, he gave a beautiful representation system called the Cartesian coordinate system. This is where your all these dimensions and the growth of and the relationship between two dimensions, all of that was envisioned. But usually the whole reason why the person gave this one was to get a system of direction. So depending on the time and age, okay, back then world was considered to be flat, so you had this. Now of course after later on we realized that we are actually living on a ball, a spherical system. So you will have a spherical coordinate system, and the way to actually pinpoint one position on Earth need not always be in terms of x comma y. It can be in terms of azimuth and elevation. So if you observe a small center of Earth and you draw a vector, so how much in longitude and how much in latitude, only two values are now enough to actually give a position on Earth. That is your lat long data. And if you add another dimension, time, now you can have latitude, longitude and time. This is enough to actually get your position data for any drones or anything that you want to calculate. And this of course is with respect to the Earth. But if it is not an Earth reference system, and if you want a generic system which is not going to be about the vector, then you would go in terms of x, y, z. X axis, y axis, z axis, that also is there. So the same thing now represented as x, y, z, comma, t. Okay, so these are all different kinds of representations of where you are. So this is how slowly we evolved. This is am I still is the screen still visible?
Yes, sir.
So this evolved into this system, right? So finding routes and directions was covered like this. But there is one more thing which was a brilliant stroke, where you are constructing a problem based on some problem that is usually observed, some finance problem. I gave this, A had this much money and B had this much money, and if C will take so much, what happens to this, right? Some questions like this were always there, finance questions usually. The whole idea, if you recall your time in the while you were when you started studying algebra, your teacher would often say, let the number be x. Remember that? This was a beautiful stroke of abstraction. Keeping the number as x, then building a new system, you would solve for x. This algebraic manipulation was the next big step, and it's a major step for human evolution. Once this abstraction came about, let the number be x, and putting the whole number system, quantizing the whole system on graphs, mathematicians got so many different ideas. Then the question started, how much of x? Okay, you got, let the number be x, but how much of x, if you want to ask the question. So that combines geometry, algebra, and variations. I'll tell you what it means. The same problem, if these two people were facing, if they did not have a land like a squarish, very well structured, defined land, what if they had a structure something like this? If they want to trade between these, where are you going to find the length? Where are you going to find the breadth? How do you even get a system to achieve this value which can be compared? This is solved by calculus. The area under the curve. How much of this area under the curve is there? So a brilliant next abstraction happened when you not just are concerned with the number being x, you're also concerned about a small part, a section being delta x, a small section. Okay, trust me, why am I saying all these things? Why am I teaching you all these things? This is the fundamental idea behind deep learning, all the algorithms, all backpropagation, all of this is handled with this delta exchange only. Okay, so I'm just giving you a different way of looking at it, so you are comfortably brought into this. Okay, now look at this number of x, how much of x. This is actually a graph. This is actually a three-dimensional graph. You have seen graphs something like this, right? This is actually a three-dimensional representation. This represents what? This represents an actual relationship between whatever is here, between this and this. This is an actual representation between a three figure, three dimension. Maybe it's x, maybe y, maybe z. Okay, so a physical thing that represent a three-dimensional change, a combined change, or a phenomena which is observed in three dimensions together will look like this. This is a physical reality of that process. Somewhere over here can be the global optimum, somewhere over here the minimum value that is required. This can be the maximum value where all of it are maximum. This can be just the minimum or one minimum and two maximums, right? Let's say you have time here as, let's say you have height, weight and salary, or let's say you have so something like that. So how height increases, weight increases, salary increases. So you want a representation for all of these, so you get this physical reality. So with this physical reality, here is the point, which is some x comma y comma z. Okay, so now this one says that this is a position where it is minimum for the height and maximum for weight and the salary, right? And you will set up a problem statement where you want to optimize for, you want to minimize, find me a situation where I will get all of this minimum, or find me a position where I'll get all of this maximum. So if you have, then you will find out some point somewhere over here for this much height, you will have this much weight and you will have this much salary. For example, if police jobs were dependent on the fitness, then this graph would make sense. Because there is at a particular weight and a particular height, your fitness will, your job or salary will get promoted, right? You will get promotion because there is a fitness element involved in getting promoted. Now, if you just have good height and if you keep on letting this weight increase, what happens to the promotion? It never happens. Your salary never increases. So if you want to map this and see where is my global optimum or the global minimum or the local optimum, you can get that hand and say this is where you want to be. So for this much weight, this is how much you can grow, and this is of course a given height, you cannot change it much. and this is what can be expected at this much height and this much weight, because you will pass the fitness level here and you probably might get this promotion, and this is what is holding in the future for you, right? Something like that. Give you an example of, because I had already mentioned height, weight and salary, so I wanted to build on the same story, and I give this. You on your own end, depending on whatever domain you're from, mechatronics, electronics, computer science, whichever thing that you're doing, you will always be dealing with many observations. So hopefully run a thought experiment and fit this reality to that. Do that. If you don't get the fit right, let's have a discussion and see how it fits. Well, having said that, x was there, let the number be x. Then we asked how much of x. Next we asked, is there an x? Is there an x actually? Simply, or are you simply saying that? Right? What is that domain? What is that next thinking line called? Probability. You have so many events that are happening. What is the probability of something which will actually happen? Right? So probability gets its own definition. It's, what is the definition of probability? Total number of favorable outcomes divided by total number of outcomes, possible outcomes, favorable outcomes by all possible outcomes, right? This is probability of some favorable outcome happening is this. Now this doesn't end here. There are certain conditions which are also there. For this to happen, after a certain event has to happen. For this to happen, before a certain event has to happen. Some more complications come in, and we will define newer ways of calculating it. Probability of A occurring after the probability of B. A and B are what? Events. Some events. Probability of you getting, let's say A is probability of you getting a job as machine learning engineer, and B is probability of you attending the summer school program. Okay, so the probability of you getting a job after you attended the summer school is equal to, this is the equation. So what does it say? Read this now. Probability of B bar A means probability of somebody attending the summer school after getting a job into probability of somebody getting a job. Forget about anything else. What is the probability that somebody gets a job divided by what is the probability that somebody will actually attend a summer school. All of these multiplied and divided together is going to give us a number which says this is the probability of you getting a job after you attended the summer school. So it shows mostly what is important. So if this number is very high, it shows that attending the summer school is very important. If this number turns out to be very less, it shows that attending the summer school is of no use, because there will be many other cases where you didn't have to just attend the summer school to go on ML and AI. There are many cases where people have got job without attending also. So all of these observations comes from data. But this conditional probability equation gives you the ability to observe that phenomena. That is probability for you. And right now I've actually shown you how your spam filter works. Spam filtering, this is the core, this is the crux of it. One more element is here, which is knife based theorem. So one more element gets added over here. When we come to that class, we will understand what that is. Okay, now with all of this said and done, the whole thing is about data and the patterns inside that data. To understand the patterns inside that data, the field of statistics takes precedence. And before I end this class today, because we are going to start with statistics in the next class, so I don't want to get into the details of it, but I want to end this with one note. Statistics is not about the number. Statistics is about the difference in the numbers. It is about intervals and ratios that you can find in those numbers. So what your statistical methods and systems does actually eventually is find out those intervals, those ratios, and how much is the drift and the variance, how much is the deviation. All of this now has been worked from what, like about 100 years now, and they have come up with a beautiful system. If you train your mind to first understand this beautiful system of statistics, this is difficult, okay? Statistics is the simplest difficult subject ever, because there is not much of calculation over there. The whole pipeline, whole system, why they have put a system like that, to dig into that requires patience. Once you get the patience and repeat it, then you will never forget it. You will start appreciating it. So, and according to me, I think it's the most simplest difficult subject, and you must have studied statistics in your own way, in your own capacity, in schools, your teachers, your father. So many people must have taught you statistics. What you learnt there is the how to. In data science, when you want to predict something, you need to learn the whys of things. Why to calculate, when to calculate what, and what to base your calculation on. All this is here. How to, unfortunately, has been taken over by whom? Who's taken over how to now, in general? Who's taking care of how to? Can one person give me who's now taking care of all the how to's? Okay, I'll start writing, you fill in the first person to open up and say, I will get a clap from me. Okay, I will start writing, fill up the blanks, you turn. Who is doing it? One. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8 letter word. I am writing. Tell me.
Commerce, I guess.
Nah, I'm putting here. Any guesses so far? No. If I put anything else now. Computer, yeah. How to is taken care of by your computer, your programming language. Technology, of course, is a good word, but I was just wanting to. Of course, you get the idea. People have said technology, statistics, and statistics. How to calculate standard deviation? Computer knows. How to calculate variance? Computer knows. How to put a machine learning algorithm such as support vector machine, k-means. Computer knows that. Everything has been coded in. But what is your work then? Why to and when to? This is you. This computer cannot know now. Of course, they are getting to this when also, okay? Computer is, after 10 years, we'll get to this when also. But this why is very, very far, far away. Because more and more problem, the nature of the problem increases. We will be depending on human intelligence to decide why. This is where you should focus on to have a any field, focus on the whys, because everything else is being taken over by computer, and rightly so, because it can do it efficiently. We don't want to get ourselves doing all this computation all the time. Life is much more beautiful than sitting and computing all the time. Let computers do it. We will enjoy the how-tos and the whys and the whens of the system and build better systems, right? With that, I think I'll end this class today. Okay, guys, hope you enjoyed it. Next class, we are going to be doing statistics, introduction to statistics. We've got a small layout here, and once it is done, we are going to be also understanding what is the layout that we are going to be using. I'll be sending you guys some extra videos to watch, which is going to help you guys download IPython notebook, Anaconda installation, or all that which is required to get the hands-on activity ready in this course. We'll be sending you the links. Watch it, follow it, and it'll be a breeze for you guys. All right, guys. Thank you. Thank you for your extra
you,
time,
sir.
20 minutes. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you.
Sir, are you available on the WhatsApp group?
Pardon?
You available on the WhatsApp group?
Yeah, I'm available on the WhatsApp group. I'll also be, if there is any doubt, I'll be here in waiting lobby. If you guys have any doubts, you can join the waiting lobby. Okay? So I'll just come over there.
Okay, sir.
Thank you. Bye.